Okay, so Unit 1, Day 3, and this is the first part of that. There'll be a second video tomorrow, I guess Monday. This guy, I don't want to say boring, but boring is never the word to use with math. This one is a little bit more, I guess, kind of the same thing over and over, just memorization. So we're going to talk about these parent functions. Just if you would really need you to memorize the shapes of these guys and be able to stay their domain and range. So first off, y equals x. This guy, just the identity function, whatever you plug in, it comes out, and you get a straight diagonal line going this way. Okay, the domain of that is from negative infinity to infinity, and the range is from negative infinity to infinity. So nothing really spectacular with that one. The squaring function, or quadratic, x squared, it's going to be that U shape. And these are just the first few points that are right on there. Make a U out of it. And the domain of this is negative infinity to infinity. You can plug anything in, you can square anything, but the range, you can't have an answer that's negative after you square it. So this is going to be from 0 on to infinity. Okay, and this one's probably the best one to show some transformations with. If I can switch some colors here for us. So if I had, say, y equals x squared plus 1, actually let's just say plus 2. X squared plus 2, that's going to take this whole graph up 2 units. Right? So if it's outside of the function, it's up and down. Okay, so I get these points right here, so the whole thing just moved up 4 units. If we did, say, y equals x plus 2, all of that squared, that's very different. The plus 2 is inside the parent function, so it's plus 2 inside there. So that's going to be left and right, and this one would end up being left. So it's going to take all these points left 2 units and complete the graph. Like that. And finally, I don't have a fourth color, but I'm just going to do negative x squared would flip that guy over. So it would be something like this, an upside down U shape. It's going to reflect it about the x-axis if there's negatives right there. Okay, so that applies to all of these. I just think that graph's like the easiest one to quickly show the translations and transformations that we do there. Now y equals x cubed. It's kind of that S shape looking one. Here's the main points that it goes through, and then if I plugged in 2 cubed is going to be 8, which I believe is off the graph. Yeah, so it's going to come up along here, kind of make a little bend, and then go up that way. Okay, now the domain of this one, it may not look like it. It's not actually going straight up. It is going over as it goes up. So it is going to the right, up and to the right. And this one is going down and to the left. It's very slowly doing it. So that is negative infinity to infinity, and the range is up and down forever. So negative infinity to infinity. Okay. The square root function on this guy, I always say this guy, like this bad boy. I guess it could be the girl too, I guess. But anyway, so it's a square root function, and this is the one, and what it's really doing is taking the parabola and it's tipping it onto its side. But when you tip it onto its side, it's going to look something like this. The bottom half gets taken out because when you square root, you plug in x values, you can't get 2 different y values. There's only one y value for it. So there's only one side to this. Kind of like a curved line going up. The domain of this, then, there are only certain values that you can square root. You can square root 0, so 0 is included. 0 is included on up to infinity, but you can't square root negatives. And then along with that, the range, because you're only plugging in negatives to square root, you can only get non-negative answers. So 0 off to infinity. The reciprocal function, and if you don't remember, if any of these you ever can't remember it, just make a t-table out of it and plug some points in. So like this guy, when I plug in 1, I get 1. When I plug in 2, I get a half. When I plug in 3, I get a third. If I plugged in a half, I'm going to get 1 divided by half, which is actually 2, and so on. So the smaller of a fraction I plug in, the actual bigger the result, because you're taking 1 divided by that, so it flips it over. So it's going to be going up this way, and there's an asymptote right here, and there's an asymptote going this way too. Because no matter what, if I have 1 and I divide by a really big number, I still have something. It's not quite 0. It can't be negative. So it makes that little shape inside there. Now you start plugging in negative numbers. If I plug in -1, 1 divided by -1 is -1. Keep plugging stuff in, and you start getting this line. It is a reflection about the origin. It's a rotation about the origin. So this one would be an odd function here. And then the domain of this guy, I can plug in any number I want except for one number. I can't plug in 0. So 1 divided by 0 is not defined. So from -infinity up to 0, not including 0, and then from 0 off to infinity. And then the range is going to get the same answer. -infinity up to 0, not including 0, and then 0 off to infinity. See, this guy, it's the reciprocal squared function. Kind of the same idea. It's going to look a lot like this, but if I've got a squared on bottom, that means there's no way I can get a negative. I plug in positives, I get positives, but if I plug in a negative, I'm going to get positives. So it takes this little arm and it flips it up. So it flips it up to here. I've heard a lot of people call this the volcano graph. There is an asymptote going down the middle. There's an asymptote going this way. So the domain is going to actually have the same domain. So -infinity up to 0 and 0 to infinity. But now the range is only positive numbers. So it's going to be from 0 to infinity. 0 is not included because I can't plug it in. Okay, so let's flip this guy over. Now yours, I don't know how yours printed out, but hopefully this is at the top of the next page. It's very frustrating. I think I did this on a few of those on the printout, but so here the absolute value function, we did some of this. This is that V-shaped one. Yeah, if you forget, you can make a t-table, but it's a V-shape. Parent function has a slope of 1 on one side. Ooh, I missed it. A little bit off there. And the other one's going to be has a -1 slope because it's going this way. Make sure I hit my points there. Okay, so the domain on the absolute value here, domain is going to be -infinity to infinity, but the range is only 0 to infinity. The exponential function, if I take anything to the 0 power, it's 1. If I took e to the first power, about 2.71, so about 2.71, somewhere in there. That kind of gives me the general shape. And all exponentials have this, has a asymptote right here, because you're taking a positive number to a power. So a positive number times itself, no matter how many times you do it, it's positive, so it's got to stay above. Now if I put positive exponents in, it's going to grow really fast. If I put negative exponents in, it actually flips it over and makes it a positive fraction. And that's why it gets really small, 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 but it never becomes 0 because I'm taking a positive number times itself. Those, sometimes I make it look like it's coming back up. It's not. It's going along this line and gradually getting up, and then it takes off. So the domain on this, -infinity to infinity. The range, 0 to infinity. We have the what's called the greatest integer function, and it's not used very often. Basically, the way I think of it is, it's kind of like drop the decimal. Okay, so if your input is 1.5, drop the decimal, the y is 1. Or 2.78, drop the decimal, the output's 2. So it kind of makes this graph where it looks like this. It goes over and it makes these stair steps. I'm going to pause and fast forward here. And this is, the left side are closed circles, the right side are open circles. So if you have like 1.99999, you drop the 9999 and you have 1. But if you have 2, now your answer is 2. So it jumps up to I'm sorry, that was 0.0. Here's 1, jumps up to 2. So it makes a stair step pattern here. So the domain of this, it might look weird, the domain is actually still negative infinity to infinity because I can plug any number in. But my range then, instead of trying to describe it with interval notation, I can't because it's not an interval. It's basically just the integers. You could say the integers. You could put dot 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 -2, -1, 0, 1, 2 dot dot dot. But it's all those integers are in the range. The cosine. So remembering cosine here, you're kind of refreshing yourself. Cosine starts up. I'll say this is 1 and this is -1 right here. So cosine always starts at 1, and it kind of makes that hill is at 0, and then it comes down and comes back up with a period of 2 pi. So let me label these axes with pi's. So I just kind of made this pi over 2, pi, 3/2 pi, and 2 pi. And it's every 2 pi is going to have a full period, so it's going to go down and come back up. That means halfway between it's here. It's going to cross there and there. Filling in these dots. And I don't want to make the straight zigzag saw shape. I want to make more of a curve here. It looks something like that. Okay, so kind of that wave, that sinusoidal wave. And the domain of this, I can plug in anything I want. I can plug in any decimal, anything. My range then only goes from -1 to 1, though. Because it's bounded from between, it's bounded below by -1 and bounded above by 1. So it's anything between -1 and 1, including -1 and 1. Okay, so now I labeled this guy, same thing, just did every half pi. So pi over 2 pi, 3/2 pi, 2 pi. Sine is basically the same thing when we shift it over. It starts at 0, and then it's going to go up to 1. Again, this is 1, and this is -1, and down like that. Okay, and then connect these guys. Make it curvy, not straight. Okay, so same thing, same curve, just slightly shifted over. Now the natural log, it's the inverse of e to the x. We'll talk about that in the future lesson. In day 5, we talk about inverses, but instead of doing this, it's going to do this. Okay, and the natural log of 0 is basically saying e to the what power equals 0. E to the first power would equal 0. So I need to go through 1 comma 0. It's going to come up along here and then shoot off to the right this way. Okay, so the domain on this, you can't plug in any negatives over here. You can't take the natural log. If you type in your calculator natural log -2, and it's going to tell you there's something wrong with you. It says error, messed up, can't do it. So it's got to be from 0 to infinity. Again, you can't use zeros, but it's the next biggest number. And then the range is -infinity to infinity. And if you notice, with this one here, the domain and range got flipped to here. And so that's what makes them inverses. And I said we'll revisit that in a couple of days. The last one is this curve that you may not have used and you may not use again after this class, but it's called the logistic function. And what it is, it actually, I'll just make this 0 and 1. It actually crosses at a half. It goes, so let's say it's bounded here. I'll put my asymptotes in. And it's bounded here, comes up, and then goes along there forever. Okay, so the domain of this is I can plug anything in I want, but my range is going to be only from 0 to 1, and 0 and 1 are asymptotes, so they're not included. Okay, so that's kind of a different one. But so this is one of those, memorize these, know these shapes, because we're going to work a lot with them this year. So just memorize the shapes, and then if you know the shapes, you can do the domain and range from the graph.